Now that we have studied the idea of the prime factorization, now we can go ahead and discuss the division algorithm, okay, which is something very fundamental, and most of us study this in high school or even earlier in the secondary school as well. So let's consider two integers a and d. So a is an arbitrary integer while d is we're considering as a positive integer. So we are considering that d is a positive integer. So in this case, given these two integers, we can find two additional integers by performing the division. One of them is called as the quotient q and the other is called as the remainder r, okay, in such a way that the remainder is always non-negative, okay, and is less than the divisor, which is this other number d. So if you look at these four numbers, we can have names for them, a terminology for these numbers. D is in this case called as the divisor, and A is dividend because that is a bigger number upon which we are dividing into parts, okay, by using the size of the each part being D, which is the divisor or the factor. Okay, I think we should avoid the name factor because factor means that it completely divides the number A. So we use this word divisor here, okay, to make this distinction. And the result of the division algorithm is again two numbers q and r, which is quotient and remainder. And we express the relationship between these four numbers in this way, that the dividend is equal to the product of divisor and quotient plus the remainder. Okay, so remainder is what is remaining once we multiply the divisor by the quotient. Okay, and a is the dividend, and we impose this constraint on the remainder that it has to be not negative, okay, or non-negative. And by definition of the division process, of course, the remainder has to be less than d, okay, otherwise we can choose q, we can replace q by q plus 1 or some bigger integer to make r smaller than d. Okay, so this is the idea of the division algorithm, that the remainder has to be non-negative and has to be less than the divisor d.